Building AI agentic solutions is hard. Or maybe it's not. But one way you can see about it is there's so many frameworks out there in the market trying to solve the same problem. But there are some frameworks which have done really well. They have not just abstracted whatever they could abstract, but they have really thought through how it would be to write code in the future to build these agents. One of them is BAML. BAML helps you write prompts in a way that I never imagined. And I'm sure if you have never worked with BAML, you would have never imagined as well. So today we are going to take a walk with the CEO of Boundary, the team behind BAML, Vaibhav Gupta, and he will walk us through an intersection of how the traditional practices can kind of merge with the new practices and how specifically they are tweaked for the LLM era and how it can give you a strategic advantage. If you're CTO, if you're VP of engineering, you should consider moving to frameworks like these as soon as possible because that will give you a strategic advantage.
But the thing I really want to talk about today is shipping agents and like how, if we're going to ship an agent, how do we do it in this era? Because now it's been 2+ years. And in 2+ years, I still see more demos than I see products. And I see very few products, even from the companies that were building demos 2 years ago. So how do we get to that point? And why are we still in this point? And what are we doing to kind of solve that problem? So I'll screen share. And what I was thinking about is how can we go and make things high quality and productive? So why are we not able to ship agents? Well, if you remember in the era of software engineering, if we build any software and it fails 1 out of 20 times, we stop whatever everyone at the company is doing and we solve that right away. There's this giant company in our neighborhood in Seattle that went through and solved this problem really, really well. They now have 3 or 4 or 5 nines of accuracy for web systems. And now we have Netflix on top of them. Amazon is that company. And because they solved networking so well, we stopped thinking about it and we just assumed things will work. And yet 2 years ago when LLMs happened, we suddenly became really accepting of software failing just 5% of the time. In fact, it changed our whole perspective on it and said, holy cow, this is amazing. But I think that's why we're in demo land, because that's not amazing. That's not how software is meant to be built. Every single one of your customers or every single one of your users of your application, any of them, will not accept things failing 5% of the time. And the foundational difference here is that really the way we have to think about software is very different. Before, only Amazon had to make their software fault tolerant. Everyone else, if I built an app on top of GitHub, I just assume the GitHub API works. I don't ever make the assumption or handle GitHub going down. If GitHub goes down, I just post on Twitter, sorry, my app is down, GitHub is down, deal with it. And everyone understands. They're okay with that. But with the world of LLMs, every single point that you call an LLM can now fail. And that means the way we write code has to be different. Not only do these really intense back-end developers have to write code in a different way, but application engineers now have to write code in a different way. So I think the best analogy to what we do when we do in AI stuff is how we used to write websites. We used to write websites as pure HTML, and then we got away from that, and then we wrote as React. Why did we write as React? Because React made it so that errors moved away from the user seeing them to the developer seeing them. When a developer forgot a slash here, the website broke, and the customer saw the error. When you use React, if I forget a slash here, the website breaks, and the developer sees the error. Moving the error earlier in the lifecycle of the product is essential to building a reliable product. Now, many of you have probably seen prompts that look something like this. If you're using any sort of AI framework, you probably have prompts that look like this. And these prompts are just not very robust. It's the same as when we are writing websites with strings. You have these magical characters. Like, what happens if you forget a slash n here? Does that change your product completely because the slash n changes what it means? And you have so many just dependencies baked into strings that are really hard to go get. And most importantly, you're tied to one model most of the time. Swapping models is really hard. And the thing that people often overlook the most is how long it takes you to actually iterate on getting to a good prompt. Now, if it takes you thousands of designs to become a great designer, and every design takes you 10 minutes to go do, that's just math. It's going to take you 10,000 minutes to become a great designer, at least.
I think this
And
is
you
a
just,
good point, Vaibhav. I
yeah,
think we know that many of the agents that we are creating are strings everywhere.
yeah,
Very hard to even remember if I've written something in that string or something. But you need
exactly.
somehow to go beyond this and say, okay, what I know it is going to be strings because we are dealing with LLM, but how can I make my life easier by maybe doing a quick iteration of what works, what not, and maybe have a record of it without actually coding for it? That I've got a bunch of prompts in my Excel. I'm going to run all of this. No, nothing of that sort. Maybe change your prompt for one thing and it breaks all other things. How do you take care of it? That's a
Yeah.
major challenge that we have. New models, I think OpenAI led the way, but obviously we are seeing so much from Hugging Face. Obviously, we want to try. Even at this moment, maybe I don't want. I'm too lazy to write my code to point it to new models. What in the future we know that we kind of need these tools to quickly switch the model and see which models perform best on my
Exactly.
tool. So that makes a
Yeah.
lot of sense. And all of this kind of comes to the last point, which is iteration loops. All of this that we just talked about, strings, new LLMs coming, maybe small language models, 8 billion, 1 billion parameters model, quick and fast. Not it all makes sense if only if you are able to iterate and make it faster.
We have one customer that was spending a lot of money on OpenAI for a while. And obviously, we all know the DeepSeek models came out not too long ago. They swapped to us. They cut their costs by 50% overnight, like without even worrying about it. And that's when they only swap a percentage of their traffic to DeepSeek. By now, the costs have probably gone down to like, I think probably like 80% of whatever they were spending before. Because they could build confidence that the model system was working by doing this gradual degradation to DeepSeek over time. But I think all these problems boil down to what we used to have in our old world of coding, which is low engineering rigor. Today, when we write code, we have such high expectations. We have Cursor should be able to auto-generate my code. I want CI/CD. I have all these automated systems double checking my work for me. But that wasn't true when code was when I was coding like 15 years ago at least. Like we had to do a lot of manual stuff, and that's why stuff broke all the time. And I think when I see agents, there's like one other main concept that I like to think about is that's very different than previous amounts of code. The the beauty and the promise of LLMs. Like models are one of the most beautiful things I've ever seen in a long time because they're so flexible. I can put anything into it and it kind of works. ChatGPT is an amazing experience. But the problem is, unless I'm building another ChatGPT clone, what I really need is I need flow of data to build reliable systems. And like if my LLM is talking to my database, it needs to make an API call somewhere. And that means I need something that can constrain this English with code and find the blend between the two. And that's what I think agents really need. Now, you've all probably seen some of these frameworks, maybe a couple more, but I'll show you a really funny blog post by Hamil Hossein. He's like a prominent fellow in the AI space. He wrote this blog post called Show Me the Prompt. And he talks about the biggest problem with any framework that you're going to go use, which is every single library promises us this magic. DSPy, every single one of them is promising us magic of like, hey, just write like 2 words and I'll somehow get you the whole pipeline to work perfectly. The fact of the matter is we're all using the same models under the hood. The only thing that's different is the prompt. Like Cursor versus Claude Code, the only thing that's different, they both use Claude 3.7. The only thing that's different is they have different prompts. So let me show you what it looks like and what you're able to get if you use a tool. And if somehow models were reliable, what could you build? So rather than showing you the code, I want to start off with like what becomes possible first. We built all sorts of interesting pipelines. We have customers like AMD, SAP, WebMD, Best Buy, and a few others now using us, along with I think like total of like 700 companies have deployed using us in production. And most of them, the favorite part that delights me the most is most people go to production within 3 weeks of starting to work with us. And the real reason that we're able to do that is because I'll show you this, let's say like this visa form from Cambodia. Typically, we might use an OCR service to go analyze this. We might use an LLM and maybe it would make things up. But this becomes possible when you use something like BAML. And this is a live demo, so we'll see if it works. If it doesn't, I'll refresh it. It should work again. So what this model is doing over here is we're running the image through an LLM. I think we're running like GPT-4o or something, or maybe GPT-4o mini. And then we're having the model generate structured data out of it. And I want you to notice something really specific. Right over here, we see first trip to Cambodia as true. But in the visa, first trip to Cambodia is yes or no with a checkbox. No OCR pipeline can ever do that. These vision models are amazing. You should use them over OCR every single time, in my opinion. We have people processing 100-page plus bank statements with vision models, and they have 0 sense of error at the end of 100 pages of processing. Prior to using vision models and working with BAML, they were actually paying, I think, about 7 figures per month to process these bank statements. Their costs now are less than 100K per year. And their accuracy is higher as well because they brought the pipeline in-house and they were able to iterate on the pipeline really, really quickly and build that expertise in-house without ever having to hire any ML people along the way. But the trick is, how do we build these systems? How do we compose it? And this works even with like real-time images. So like I have a bunch of weird things that we can go through, but I think the most interesting one is like it works with audio, text, PDF, images, audio, like handwritten text. I have like I don't know, I have like a $20 bill. So like, watch this. Let's see if this works. It's always scary to do anytime I run it live, but the thing about BAML is because I know it's going to work, I can run it live because I have the confidence for it to just work. You can see what it's doing. It's wearing live court over like a blue shirt, which my shirt is either blue or purple. It's holding up color, and I'm holding a paper currency bill. It's a $20 bill. It's a US dollar, and it says it's an indoor environment like a laboratory setting. Man, I should put some paintings in my wall to make it not feel like a lab. But the point is that these again, I have like all sorts of other documents I can run through, handwritten text, anything. These models are really flexible and really beautiful. It's just a matter of how you constrain them to make them reliable.
One point that I would like to make for all the viewers who may not have done anything with BAML, whatever Vaibhav showed here is something that is possible because we have put some constraints into the BAML and the way you will use it so that you are able to reach this kind of outputs, kind of orchestrate your flow better.
So let's show you exactly what is BAML. Like, what is this word that I've been saying? Firstly, it's not Bank of America Merrill Lynch. I know I worked in a hedge fund for a long time. It stands for basically a made-up language. And what BAML is BAML is our attempt to modernize prompting workflows and agentic workflows. Let me do this. And here's how we do it. Okay, there we go. So what is BAML? BAML is a file format that you can add into any project, Python, TypeScript, Ruby, Java, Go, C++, anything you want. You can create BAML files inside of this folder, and you can start looking at them. BAML will syntax highlight your prompts for you, and it does a couple of things just to make your ergonomics of writing prompts better. But better than just making ergonomics better, it actually makes your prompts better. So let's look at what it means to write a prompt in BAML. Most frameworks treat LLMs as a high-level concept. BAML is designed to where, yes, that's what BAML stands for, basically a made-up language. I can tell you the secret name it stands for if your boss isn't around later. But if in BAML, everything is a function. Functions have inputs and functions have outputs. In this case, I have a function named extract resume. It takes in a string or an image type, and I'll show you how we do multimodal. And it outputs a resume data model. What is a resume data model? Click on this. It's defined in your code. A resume data model has a field name, a field email, and an experience, which is an array of experiences. And then it defines what model it's going to go use. So unlike functions in regular programming languages, functions in BAML execute via an LLM. So normally code operates with if statements, for loops, and everything else. We just say an LLM is an operation that happens. In this case, the client is defined over here. I'm going to use OpenAI fallback. I'll show what that means, and you can see right here. It's a fallback system, so I'll describe what that is in a second, that tries GPT-4o Mini and then tries Sonnet afterwards. And then I write my prompt. Our prompt is allows you to write any sort of for loops, if statements, anything else that you want. The compiler is, I don't know if that's a joke or not, but the compiler, BAML is built under Rust, so it's quite fast under the hood. But the place where BAML starts to be very different than everything else is instead of writing your prompt and stopping, we go a step further. we have this button here in your editor directly built in called Open Playground. Let's see what it does. It opens this playground for you right in your editor of your choice. And soon we'll have NeoVim and JetBrains support as well. But in all cursor VS Code. And you'll notice a few things. This is a real-time preview of that prompt. Remember when that blog post showed me the prompt? That's true. To write really good ML pipelines, you have to be able to see the prompt. Anything I write in this prompt will show up in real time as I'm writing it. This is your hot reload loop for your prompt. What is CTX.output format? These are instructions to add in the return type of my prompt. If I change this from a resume to a resume array, my instructions change to mimic that. If I change email to be an email array, my instructions change to mimic that. It's a thing you don't have to worry about. And most importantly, we show you exactly what the prompt is going to be. If I change my inputs, it highlights it. Why do we highlight your input? Because prompts are just strings, but I really want to know what is my input versus my base prompt baked into it. So we make that really, really easy for you to see. On top of that, we give you a tokenizer. Why do you want to be able to see the tokens? How do we know how many dashes are actually the right number of dashes? It turns out this actually creates one more token to use 2 more dashes. This is 1 token. I should use the 1 token approach, not 2. It's just going to be cheaper, and it's not just cheaper, it's making the problem easier for the model. The model would have to think more if it has to take out 2 tokens, not 1. So we give you the tooling so you can just stay in your editor and really deeply understand what's going on. Now, fundamentally, everyone here knows that BAML does not have an LLM baked in. It's just going to go call an LLM API. That's what we all use. Well, we show you the exact web request that's being fired out. So not only can you debug and see with the tokens, not only can you see the full prompt, but we show you the full web request under the hood. So there's no magic at all. There's no prompt being added. There's no magic string that BAML has baked in. What you write here is the prompt that goes out. And you can see over here, it's going to GPT-4o Mini. But why is it going to GPT-4o Mini? Let's dig deeper. Well, it turns out OpenAI fallback is described right over here. It has GPT-4o Mini, waits 300 milliseconds, tries GPT-4o Mini, and then goes to Sonnet. If I look at Sonnet, you'll see my web request changes because Sonnet has a different web request format than OpenAI. So if you ever don't like something, you're actually able to really quickly understand and see what it's doing for any of the models under the hood at any point of your pipeline. Now, why is this system waiting 300 milliseconds? Well, it's because I told it to in my code. Custom GPT-4o Mini, this one, has a retry policy baked into it called exponential. Exponential has max retries of 1. Let's change that to 3. My UI changes to go mimic that. So as a developer, I can really quickly understand what my system is doing under the hood and go reflect on it and debug it much faster. But the part where BAML really stops and that you iterate 10 times faster than any other system is this purple button up here. That's because whenever you have unit tests, wouldn't it be nice if you could just run them really fast? You press run and it just works. And what we do over here is we take this test case and we run it through the prompt. Now, BAML has done 3 things for you in here, to be very clear. It helped you assemble the prompt from this input into a prompt HTTP request. It actually made the request on your behalf. And lastly, it did one last important thing. It actually parses the response coming out of the model into the data model of your choice. And we do this without any LLMs, and we do this in under 2 milliseconds on your machine without any remote network calls.
Vaibhav, it will take 2 minutes just to go through whatever we have covered because I guess we have covered a lot. On the left side, you write your code. On the right side, you have got your playground that is connected to your code. So you get a view of what prompt you are writing and the exact way it is going to the LLM in 3 ways. One is prompt view. You can see the raw curl view that this is exactly the same with the API key and everything that is going out there. And the first one was the prompt view itself. Then at the bottom, you have got a view on your test set because every time you make a change your prompt and then you see it. On the left side, this is the raw LLM response, and on the right side is where BAML is kind of has done something magical under the hood, which gives you the object that you want even with chain of thought So if you see on the left side, you've got a bunch of stuff that you really don't need. Maybe you ask for reasoning and LLM kind of gave it to you. But at the bottom, you've got the actual object that you will use to make further decisions in your pipelines. So that is what comes out of the box if you see at the right. So you don't have to worry if even if you are prompting with chain of prompting or reasoning kind of thing, it will get you the object that you need for your flow further without, and this is without any LLM. It's not like I got this input that is there in the raw LLM response that has the reasoning and the object that I'm looking for. It's not sending it to LLM, but rather there is a coursing function that they've written that kind of extracts the JSON.
For example, the thing the model spit out had a bunch of chain of thought and reasoning because I told it to. I said, before answering, list 3 incredible achievements of the person. And then the blob here actually doesn't even have it. It's not even JSON valid. There's no quotation marks around. There's strings with spaces without quotation marks. And yet the data model you have here is perfectly compliant. That's what we do. We take the burden of the LLM having to produce structured data and we remove that from the model. The model can produce anything it wants and we turn it into structured data for you automatically. And we do this for all sorts of errors. And I think I can show some metrics on this later, and we'll have a paper that'll be coming out later this year, hopefully, and we've been working on. But what we've shown is actually using our technique, GPT-3.5 with our technique is actually outperforming GPT-4o with structured outputs. And we're able to achieve like much higher accuracy on any kind of model. So even models that don't support structured outputs can take advantage of this technique along the way.
That's pretty. That is what I eventually liked about this Vaibhav, that I really don't have to worry about getting a structured output. And even with the world moving towards small language models, less number of parameters, 1 billion, 3 billion, if I can get the same output, this is huge. This is huge.
Exactly. Now, I want to talk about a few more things. Let's say BAML is interesting and you want to consider using it. At some point, you probably don't want to write your whole application in BAML. You probably want to go back to Python, TypeScript, Ruby, Java, Go. That's where BAML plugs into every other language of your choice. And here's how it works. We have a function that we wrote, extract resume. You do from BAML client, import B, and you get resume equals b.extract resume. And already you can do resume.experience. And resume.experience is going to be sometimes Python language server is a little funky. Resume.experience is going to be a list of experiences. If I go back to my BAML code and I change experience to be a string array instead of an experience array, my Python code will reflect that and it'll change this to be a list of strings. And it'll be a list of strings. So you get really good autocomplete in any language of your choice by default with error checking built in, because BAML actually generates code for every single language from BAML code to create perfect data models. So you actually get pedantic data models for everything you can do. And this is now available because this gets auto-generated from here under the hood. So it just helps speed up your development cycle because you think about prompts in LM world and prompts in BAML world, and then you think about how to compose them with agents in Python or any other language of your choice. And it just takes away some of the burden because no matter what happens, no matter what chain of thought or reasoning I do, no matter what retries I end up doing, this resume data model will always be a resume. Python is so bad. I have to restart. So this data model will always be a resume, no matter what I do. And that means it's just a burden off my shoulders because now instead of treating the LLM as this magic box where I have to write things like, I'll tip you $5 to give me the right answer, actually I'll tip you $1,000 to give me the right answer, you can do more techniques that are actually mathematical, such as before answering, list 3 incredible achievements of this person, because that's going to help me get a better answer. I'll pause here and see if anyone has any questions, but if not, I'll go into like a couple examples.
Yeah, a question on the cost saving side. I understand in the
Yeah.
beginning we talked about lots of cost savings that customers who have already been
Yeah.
using BAML have received, right? So
Yeah.
I saw one of the things which you mentioned about is the tokens, like you could identify the tokens on the right hand side and see like reducing any characters would save you tokens.
Yeah.
So apart from that step, what else do you think
Let
that
me
this tool provides?
let me show you. So I think one big thing is every other framework that does structured outputs, here's what they do whenever structured outputs fail. They call the model again. That's just twice the calls just to get good structured outputs. We never do that. We only call the model once. And we can do that because we can do error correction. If you use Pydantic, Instructor, or anything else, and they get this data model out of the model, they're just going to call it one more time. And that's just going to double your cost. That's all that's going to do. I'll show you what we do in this scenario. So here's the model spitting out valid JSON. This is 129 in, 99 out. I want you to note something really fast. Let me switch on, please. 129 previously, 99 after. I just reduced this for free really quickly from 139 in. I increased the input tokens by 10 and I reduced the output tokens by 5. Let's make this a little bit more complicated with a little bit more of a schema, and I'll run this again. Now 73 tokens out. Oh, Nico, I know. Versus, and I'll remove this string again. And that's 90 tokens. So just by adding that one string, which was don't add quotes around keys, I went from 90 tokens to 73 tokens. That is a cost savings off the bat for free of
Right.
20%.
I think to go, if you can go to the prompt view in the,
Oh yeah.
the fundamental difference that I see whenever you use Agentic AI or any other framework, the way it describes it is, if you see the request going through the network, you will see a bunch of JSON with the JSON schema, not the JSON exactly, but the schema. This is this is my JSON property. This is the type of that property, bunch of stuff around it. But if you look at the prompt that BAML just sent, it is not that. If you see, we have written it in plain English, without the quotes, without the description, adding those words that you typically see in a JSON schema. Right, that is way bigger.
Exactly. So normally if you use Pydantic or something else and you to get like a string array out, you're going to spend 23 tokens using OpenAI. We can talk about different models later. But you can do the same thing in 2 tokens. That's just 10x less tokens for the same data model. This is 23 tokens, this is 10x. And there's no difference in understanding this data at all. There's zero difference, but it's just 10 times cheaper. Similarly, for this one, this is 27 tokens to send this data out. But if I suddenly wanted to make it a string array, it's still, because I said string array, this is still 27 tokens. If I do this with Pydantic, I would have 23 more tokens to add on top of this, on top of my 27, because I would have to do the whole thing with string array. And it's not just about tokens, it's also about just the comprehension of the problem. If I take this data model that says I want skew and quantity to be required, I want you as a reader to think about how much work you have to do to first read this data model and then read required and be like, oh, I have to jump back and associate this word with this. All these tokens are associated with being required. All these tokens are associated with being required. And this one's associated with not being required. That's so much backtracking that I have to do every time to understand this. And when I have a simple model, that's okay. But the more complex my system gets, the harder that gets to be. And that's why if you do it this way, same exact information is going out. But I can represent something from 73 tokens down to 26 tokens without actually losing any information. And that's what BAML does. We have a bunch of algorithms that we've invented that actually help you reduce tokens for free at the compiler layer. But then also we do a bunch of reductions on the output token layer as well. So you can win on both ends.
We'll cover that in a future session because it has a multiplying effect. You do it now and that call is gonna run forever for next, let's say, 6 months in production. It is a huge impact that we can bring to our clients. You have a question.
Yes.
Thank you, Anmol. So, Vaibhav, like you have already shown, and like for example, Python, we can utilize the BAML code. So, is the reverse possible as well?
What's the reverse in your mind?
Like in BAML, we can use a different programming language code. We can utilize those existing components.
So usually what we do is we just port the data models that you have into BAML, and then we have a way to import stuff dynamically into BAML as well from Python. But usually what most people end up doing is they actually define their data models in BAML. And I'll give you a reason as to why. Think about your front-end code and your database code. Usually when you have a database model and a front-end model, you usually just create two different models because you don't want leakage between the two of them. And you just build an adapter. And think about an LLM as a new type of interface that you need to build a data model for. Because the data model that goes into an LLM will often be different than the data model you want to save in your data system and the data model you want to show your user as well at the same time. So most people, even in practice, they aspirationally want to go do that. But what we find is if you do that, then you bring in a lot of bloat from your existing system that you didn't need. And that is what goes into the model. And that just reduces your accuracy. And it's better to start from something that's a little bit more bespoke.
What you asked is a valid thing, and what Vaibhav spoke about is possible solution. But we do have something that quite relates to this as well that we'll cover in this call only. So we'll wait till that point, and once that comes, I'll answer that question.
Thank you.
Yeah, and then they mentioned that it was definitely lower latency. That's definitely true. It's a lot less latency. It's not just cheaper. So most apps will get a lot faster when you switch to BAML. For that reason, we have one customer that had a 5-minute AI pipeline, and they swapped all their pipeline. They had like 50 different calls that they were making. They swapped their pipeline to BAML, and then their pipeline went down to under 30 seconds. And that was just by migrating to BAML. Their prompts got a lot smaller, their inputs got smaller, and their outputs got way shorter as well. And a lot of this stuff has compounding effects in a way that a lot of people don't expect. So like, for example, when I see most people's prompts, I see their prompts being very, very long. But you'll notice that this prompt has no noise. It's a very short prompt. And most of my magic or my efforts go into here. So I can add things like add description, the name of the company. Now let's take a practical example really quickly and say, what if I don't want Gmail emails to come in here? I can just say add description, only non-Gmail emails are allowed. And I can see what this does. And you can see for my test case, I have this email. That's not my real email. I'll post my other one later. And it still does it. Like I'm even though I'm prompting it, I wrote in the prompt, only non-Gmails are allowed. And you can see right over here, it still does the Gmail email. So how can we blend software with LLMs to go get advantage of this? Well, the way you do this in BAML is like this. Instead of having the LLM do this, what if we could just say this? We have a thing called a non-Gmail email, which is a string, which will guarantee is not allowed to have gmail.com in it. And we'll change our type to be a non-Gmail email optionally, because it's also, as we know, it's a non-Gmail email. So the prompt is still very similar. We don't even put instructions about it being a non-Gmail anywhere. But then we run the model. The model does its thing, but we got null out of the model. Why? Because BAML looked at this string that came out of it. It said the string did not meet the conditions it was required to meet. And said the next best candidate was a null option that you allowed me to have. So you can actually find this blend between software, which is highly reliable, and LLMs, which are highly flexible. Put them together and get the best of both. And this is one way to reduce hallucinations. You
I
can
would
start
like
doing
to
this.
add one more point here. I think in the past we have been doing this kind of assertions, but either they are part of the post-processing code, or either you
Exactly.
specifically say it in the prompt that,
Prompt.
hey, please do not give me at Gmail and beg for it to come. I think this kind of helps us to do that even on the granular level of our classes. For example, here we took resume, and then the most granular class was a type on Gmail address, and we put an assertion on top of it. It's just like I'm using Agentic to do some kind of class validation, writing rules there, but at the most granular level that possible. And with this, is
For everyone on my team, the way I looked at good design practices is if something is hard to do, my engineers are not going to do it. Even though they know it's good to do, they won't do it. If CI/CD didn't automatically run, no one would run tests. And it's not because everyone is bad. It's just because automation is what we need. We want to rely on processes, not people, so people can put their mental energy into things that are actually hard. And the thing that I want to put my energy into is knowing that I don't want a Gmail email here. Not the 50 different ways I have to prompt the LLM to not have a Gmail email in there. So the easiest way to do that is just to tell the LLM, just not ignore the LLM completely and simply tell the system that it has to do it this way. Now you can go a little bit further and let's take a look at this company. Now, whenever I'm running a resume, people write their company names in like totally different ways. So like I might write MSFT for Microsoft instead of Microsoft. But if I'm building an ATP, we have a predefined. The question asked was, we have a predefined library available in BAML, or can we also have the option to create our own library? You can actually create everything on your own. BAML is fully flexible. You can do recursive types. So you can create a type that looks like this, type article. Oops, not type, class article, title, content. We can do content. And then we can even do like sub-articles. And you can build a fully recursive system in BAML. You can build like a tree. You can build a class node. And then like value string. And you can build recursive types or anything. So you actually have the ability to build any sorts of code in BAML. Any sort of data model should be representable in BAML as you wish. But as I was saying, let's say I wanted to standardize this company name. I want the legal entity company name. Let's just try it. A description, legal name of the company. Let's just try what it does and see what it outputs. It sounds like it didn't really listen to me, even though, again, it's in the prompt. Every time I write description, it's in the prompt. Yeah, I won't show that next time. So the first thing you'll notice is I had an idea. I wrote it in like 2 seconds, and I ran the test. And I just immediately was able to see whether or not it worked. I saw it didn't work, so now I can try something new. Let's try something else. Instead of company being a string, let's make it a company class. Class company. Let's, yeah, I guess we support enums as well. Name, and then what I'll say is I'll add another field called legal name, which is a string. But let's try this, and then I'll say like company type, and that's a good one. I'll have an enum that says, well, whether or not it's a well-known company, or whether it's a likely good guess, or maybe it's an unknown company. Like an LLM probably doesn't know about our company. We've only been around for like about 1.5 years now, or 2 years now. So now what happens when I run this? And you can say that it said the legal name was likely no. Let's move this. Let's move company type over here. And then description, best guess, the legal name of the company if it looks like a established. Let's just run this. And now you're able to see what it was able to do. It did Google LLC and Microsoft Corporation. But I'm able to iterate very quickly and get this out. And now in Python, I can be pretty confident that legal name will exist for most companies. And obviously for BAML, it says unknown company, legal name null. So it can help you standardize things as one possible thing you can build in BAML. But the most important part is you have an idea, you just change your code, you press play, and you iterate very quickly. I'm going to show one last thing. Now, all of you are probably wondering, it's like, okay, fine, maybe this thing is cool, maybe it'll help me, but it might be hard to go use. Because even if I go use in Python or something else, like how do I go do it? Well, the best part is you don't have to. You just ask this chat bot that we have over here. I can post a link later. Let's just say we want to go do this. I want to extract a resume, or let's say I want to analyze a newsletter for new company announcements, new company funding rounds. Let's say that's what I wanted to go build.
this particular.
So it's not fine-tuned. There's no fine-tuning at all. And this, for me, did a couple of things. It actually built me the whole project. It described the funding round. It said the company name, the funding amount, funding stage, investors, and it kind of made assumptions about what the data model looks like. That descriptions for everything accordingly. It wrote the function for me. It decided that in this case, it should use Anthropic 3.5 Sonnet because it might be a slightly harder problem than for GPT-4o Mini or some other small model. And then it actually made test cases. And I can run these test cases right here. So with iteration loops, I can actually go run this and see what BAML outputted, and I can obviously copy and paste this, bring it back into VS Code, and start iterating here as well. If I want funding dot. And now I have this thing right over here. I open this in the playground and run this locally if I want.
You asked a question around it. This is where you can quickly take your existing classes and bunch of stuff, put it here, and it will give you something matching very quickly. So we want to solve that problem. Maybe not exactly, but you got to work now.
It might actually improve the data model for the LM as well while it's at it, because most people's data models that we see are just not good. For a lot of problems, especially for LM. They can just be simplified often to be more representative. So it might give you something slightly different because we've optimized this engine to really give you good starting points.
This is great. And for those who don't even have an ID, I think I wrote about this in my email when I asked to everyone to attend this session. This is what I meant, that you need not to have an ID. You currently have a chat where you can exactly see your code. You can actually run it right there without even writing a single code and see what prompts work or not. Maybe if you are a product owner acting for a client, this is the place where you play and then let the developers handle it. With
And
that,
you're going to share.
Okay, with that, I think, Vaibhav, let me share my screen with some of the things that I have done, and I'll just quickly recap all the things that we have done. I want you to get a bird eye view of what is available to you. So focus on BAML source. This is what is a basic folder structure. Whenever you install BAML, you have to do some kind of init command. That's a one command like pip install kind of thing, and it gives you this folder where it gives you basically three things. One is the clients file. This defines your LLMs and the various strategies that you have around how do you retry and fallback kind of stuff. You can define it here. Then in your team, if you're people coming from data background or people coming from web development background, you have got the option to change your generated code in Python, TypeScript, Ruby. Third thing, you will get a basic BAML agent. You have to create your user query, how the user query you will send, and what is the output that you are expecting from, and then you write your function. You can test it in the playground, and then you can write a bunch of tests. For example, here I've written, imagine that I'm creating a human proxy and this human will interact with it, and there would be a bunch of outputs that are expected, and it's a to and fro conversation that is going to happen. So multi-turn conversation and a written test for, let's say, just one out of syllabus question, because my bot here is not supposed to answer these questions. So that's a test set for me. How does it react? Then I've written another test where I'm giving some incomplete information. That's an incomplete question that I'm posting it, and I'm checking how does the LLM reply. Then I've got another test which I've got double turn, multi-turn conversation where I say, hey, here is the conversation. What should be the next answer? So all these I'm able to iterate quickly by just running run test, and it will run on the right side just the way Vaibhav explained it. On top of it, if you are into multimodal, you have this fiddler. If you come here and say extract receipt. So if you are working with multimodal in the playground, it does support image and the audio at this moment, I believe, which I tested with. And there is a whole lot of stuff that you can do, chain of thought. Symbol tuning is something that I specifically learned when I was working with BAML only, but it is quite a novel thinking that a paper published, I think, in 2023. All it is saying that, hey, you have got a bunch of categories that you want to categorize the particular prompt in or whatever user input it, rather than telling it what could be the category. Don't tell LLM that it is a refund category. Instead, let the LLM decide saying depending upon the description, and then come back saying K1. But all this is baked in within BAML. You don't have to worry about getting an extract saying that K1 is the category. It will automatically kind of give you the refund as a category for your downstream processes. So that's a great abstraction that I liked. Finally, the product that coming to the product that we are building, we currently internally are building a NL2 SQL thing. For that, I have so far been able to create human proxy agent, and then there is a table expert agent that I've created, written a bunch of tests around it. All its job is figure out all the tables that can answer help query for a user, and then a column expert. So I've reached so far. I think it is good. With that thought, I think we have still 2 minutes. Anybody has any questions?
One last thing I'll add is, like I said, BAML is completely open source. It's under Apache 2 license, so it's available. It should be available for use in any company. We have teams at Amazon that use it. We passed through security review. And it has no network dependency. So even in the most, I know people run it on US Gov Cloud. So like in the most secure environments, through every little bit of scrutiny, we're able to actually go run it there as well. So like there should be, really the thing about BAML is we designed it because our team loves code. Code is my favorite form of art. And we just want to help everyone write beautiful code, because beautiful code has a couple of side benefits, but the biggest one is that everything is maintainable and readable, not just for your team today, but for your team tomorrow, and for agents that might update your code base later as well, because readable code is editable code. And that's the goal of BAML, to remove all this prompt engineering voodoo and give you reliable, maintainable pipelines that we can treat with software principles. So thank you guys for having me. It was a real pleasure.
Hope you enjoyed this session and found it insightful. I truly hope you're walking away with something valuable that will support you on your journey towards building agentic solutions and driving greater outcomes for your clients. Until next time, keep building, keep experimenting.